Hey everyone, today we're going to take a look at doing some of these Koppen classification data sets. So I've given you a series of different locations around the world, and the goal is to practice using the Koppen classification flowchart or decision tree to ultimately come to the conclusion about what is the classification for that site. Just a side note about these classifications, this really stands as the purpose behind biomes, or really I should say the justification behind biomes. You've heard about these in biology before. Really, in biology, we teach them driven by the different biota that is present, so plants and animals. From an Earth systems perspective, really what drives these is the precipitation and temperature. So it's climatological data that drives what animals are going to be present, what plants will be present there. So we want to take a look at this from an Earth systems perspective, and this is the kind of the classic classification system that we use in this field in Earth sciences. So once you've gone through kind of what I would call the background notes, kind of explaining each one of the classifications, the A, B, C, D, or E climates, these are the other two files that I have attached to that assignment. So kind of behind the scenes here, we're going to take a look today at the Moscow example. So I'll do the first one with you. The other 5 cities are just down below. The flow chart then, this is what you're looking at. What looks at first glance to be kind of a series of convoluted boxes and data points. Really what this represents is somewhat of a classic dichotomous key, a series of yes or no answers that ultimately bring you to what I have underlined in red in each one of these. These are your specific Koppen classifications for these different climates. You can kind of see them all spread out over this table. Somewhat of a side note about this classification chart, what you're actually looking at is, I believe it's a picture I took of a document that was a copy from my graduate prof way back when. So this goes many, many decades back to my background in earth and environmental sciences. So passing some of the legacy on to you with this document. I could try to retype it, but I'd lose my mind. So again, welcome back to like the 1930s of tech here. So anyway, on we go, looking at Moscow. The two principal numbers that you're going to be focusing a lot on are going to be these two on the right-hand side, the mean annual values. We have a mean annual temperature, that's in degrees Fahrenheit, and then we have a mean annual precipitation in inches. We deal primarily here, of course, as Americans, we have to deal with the imperial system. You can also use these using the metric system, but not much difference, just different values. So we've got, again, our mean annual temperature and our mean annual precipitation. So we're going to go to our flow chart here, and apologize for the slow computer. Always start in the upper left-hand corner, kind of got this big arrow drawn up here on the right-hand side, sorry, on the left-hand side. This is going to be my starting location. And this is always going to be the initial first question we ask. So is every T less than 50? I would point out the main key here highlighted to yellow is that our capital T is in reference to average monthly temperature. Our capital P is in reference to average monthly precipitation. So the first question asks us, is every average monthly temperature less than 50 degrees Fahrenheit? If we go back to Moscow's data, is every one less than 50? And we can see here April and May and June and July and August. These numbers are all above 50 degrees. So our first question we would want to answer as good old no. Is every temperature less than 50? No, it is not. So we're going to move on then to our next box here. And the question asks, is it a B climate? Use graph 1 on the next page. So here on your documents, you're going to slide to the second page. And you're going to find actually 3 graph 1s. And the difference between these 3 graph 1s are based on the distribution of precipitation. Do we have precipitation distributed pretty evenly, meaning we get precipitation during the summer and winter months and generally the same amount. Do we see precipitation as a summer concentration? So it's very dry in the winter, very wet in the summer. Very wet in the summer. Or is it winter concentration where we have very little precipitation in summer months and a lot of precipitation in the winter months? Now, for clarification's sake, we take a look at what is constituted as winter. The winter season in the northern hemisphere is considered November through April. This, of course, would be flipped in the southern hemisphere. So in the southern hemisphere, November through April would be considered our summer season. So just kind of make sure you're keeping that straight. Even in one of the questions, you can see the last location, Cairns, Australia. I make it the point of saying this is in the southern hemisphere. It's going to flip things around for you. So again, we're using graphs A, B, or C based on the seasonality of precipitation. When are we getting the precip? Is it in the summer or the winter? Or evenly distributed? So we take a look at Moscow and our precipitation. It's pretty evenly distributed. We've got some ups and downs, but there's no one distinct month of precipitation. There's no one distinct season for precip. It's pretty much happening year round. So if we take a look at that, we're going to use, for graph 1, we are going to use our even distribution graph. So here we go. Okay, now to use this graph, we need two values. We need our mean annual precipitation and our mean annual temperature. Our horizontal axis is precip. Our vertical axis is temperature. So again, we need to go back here to Moscow's data. We've got our mean annual temperature of 48.5 degrees and our mean annual precipitation of 19.8 inches. So 48.5 and 19.8. Come back here to our graph. I'm just going to sketch this one in. We've got 48.5 mean annual temperature. It's going to put us right about there. And 19.8, our mean annual precipitation is right there. Find the intersection point. You don't have to be perfect on this, but you kind of get a sense. And we intersect right here. Now, where that's key is this. Does it fall in one of our two B climates? If we think back to the flow chart, the original question asked, is it a B climate? Does it fall within this BW triangle? Does it fall within the BS triangle? Or does it fall outside in a humid climate? We can see our intersection point is here. So why are there going to be an A, a C, a D, or an E climate, but definitely not a B? So if we go back to our original flowchart question, is it a B climate? We can now say, no, it is not. So we're going to move on down to the next question. Is every temperature greater than 64? You may remember when you looked at the data last, is every temperature greater than 64? We can see for Moscow, computer does not enjoy me right now. Is every temperature greater than 64? And most definitely, no. It is brutally Soviet cold in the wintertime there. So average temperature, no, we are not. So we go to our graph again. Is every temperature greater than 64? Nope. Is every temperature greater than 32 degrees Fahrenheit? We just looked at that thing, so no, we saw 25 degrees, so nope. We're going to carry on down. Now this one takes a little bit of thinking. Is the driest winter, P, the driest winter precipitation, is it less than 1/10 of the wettest summer month? So let's take a look at our data to see if we can make sense of what that's asking about. So is the driest winter, so we have to identify this, so our driest winter month is going to be April at 0.95. Is that less than 1/10 of the wettest summer month? Our wettest summer month is June. So pretty obviously we can see is 0.95 less than 1/10 of 2.33? No. So here we are again answering no to our flowchart question. Is the driest winter precipitation less than 1/10 of the wettest summer month? And we would have to say no. Next question. Is the coldest temperature less than 36 degrees, is it less than negative 36 degrees Fahrenheit? Pay attention to that negative sign. Looking at Moscow's data, we can see that no, even though it's brutally cold, it is not less than negative 36. Heaven forbid. So the answer to that one is no, it is not less than 36. Is the hottest temperature greater than 72 degrees Fahrenheit? Go back up to the data. And now that my computer is completely going on the fritz, is it less than 72? And we can see July, we have a 75 degree temperature here. So we are greater than that 72 degree cutoff. And is the hottest temperature greater than 72 degrees Fahrenheit? Here's where we're able to say yes. And there we have our end, our terminus. We have identified this location as a DFA DWA Koppen classification. So on our answer sheet here, we would write a DFA /DWA Koppen classification. And there we have it. So kind of long drawn out explanation here, but this is going through the first of those examples. You'll probably be a whole lot faster without having to zoom in and out all the time like that. Take a look at these, go through and classify. And again, the purpose behind this is looking at the classification for these different biomes. All right, good luck, everyone.